Good afternoon and welcome back. I am pleased to introduce Richard Smith, who's going to do our next talk. I also would like to give him a token of our appreciation for being a speaker. Richard Smith is a senior consultant with Security Risk Advisors, working primarily on security data pipeline efficiency and onboarding clients into SRA's XDR solution, Scalar. This is his third year presenting at BSidesROC. Take it away.
Hey. All right, yes. Hi, everyone. So in case you didn't pick up from Kathy just there, I'm with Security Risk Advisors, who are one of the sponsors of this event. Check out our table out there after this talk. It's a straight shot from this room. We have stickers. We had socks. We have all kinds of goodies to take home. So make sure to stop by and have a chat with one of our folks there. And that's all the corporate shilling I'm going to do. Introducing myself, my name is Richard Smith. I am a senior consultant with Security Risk Advisors. On a day-to-day basis, most of what I do is building secure data pipelines for clients and getting clients onboarded into our XDR solution, and just basically helping clients to both save money and improve their security posture at the same time. I have a presence on social media. It's not a huge presence, but that over there is that's my presence on Blue Sky and Mastodon. If you want to get in touch with me, you can also email me, richard.smith@sra.io. So there we are. So just a little bit of background to what I'm going to be talking about today. So the central problem that we're dealing with here is that Microsoft, until recently, hid vital logs behind a paywall, essentially. Until late 2023, the premium audit features, which would include things like access to audit logs showing when a mail item was viewed or when a file was accessed, were only available to customers who had the premium E5 or G5 or A5 licensing. So, if you were an org without E5 licenses, which, by the way, cost about 60% more than an E3 license, and because of that, a lot of organizations do not pay for that premium licensing. So if you are one of those organizations and you had a cyber incident, like, let's say, a compromised user account that had access to a mailbox that contained sensitive information, you had no idea what the hacker had seen if you had that kind of a compromise. So to reiterate, without access to the premium audit logs, which are only available or were only available with E5 licensing, you basically had to assume in the event of a compromise that the intruder saw everything in that email account. You had to report that they saw everything. And if you're in a regulated industry, you will be fined as if they saw everything. And that adds up pretty quick, as I'm sure a lot of us are aware. Most data breaches that get reported are affected in some way by this auditing gap. I'll just give a couple of examples briefly. One from May of last year, Perry Johnson and Associates, medical and transcription company. There was a major data breach that it was estimated that over 8.9 million customers were impacted. Another one from a bit longer ago, July 2015, medical informatics engineering suffered a breach, and there were 3.9 million impacted by that. However, it's likely that in a majority of these cases, these breaches, the actual number of records that were accessed is a lot lower than what's reported because of the issue that I've just talked about with log visibility and people not having access to the audit logs that would tell them exactly what was accessed. In July of 2023, the CISA, the government agency, recognized that Microsoft's premium audit level is needed in most organizations. And I've just included a snippet here of the actual guidance published by CISA, which says that in addition to regular audit logging, CISA and the FBI strongly encourage organizations to enable per-view audit premium logging. The very next sentence there is that this logging requires licensing at the G5, E5 level. So there we have it. I mean, CISA is basically saying here in official guidance, you need this logging level, and it's going to cost, it's behind a paywall. It's going to cost you 60% more, but you need it. Very shortly after that guidance was published, Microsoft was accused of having a pay-to-play approach to security. I've just included a screenshot here from Ars Technica that says exactly that, and this was from July 14th. That was 2 days after CISA published this guidance. Over the next short while, both the press and the user community and just basically a lot of different parties put a lot of pressure on Microsoft, and by July 20th, Microsoft had started saying that they are going to stop locking those security logs behind the E5 paywall. So Microsoft was basically, they had their arm twisted and they were forced to expand access to those logs. They weren't very happy about it, and they frankly weren't very chatty about it either. This little snippet that I've put here just indicates just the extent of what Microsoft had to say about it, which is, over the coming months, we will include access to wider cloud security logs for our worldwide customers at no additional cost. Very carefully chosen words. Over the coming months, we will include access to wider cloud security logs. Notice they're not saying immediately. They're not saying you have this access. We're saying we are going to, at some point in the future, enable you to gain access to these logs. So, summing up the situation since July 2023, Microsoft have been forced to enable access to vital audit logs for customers who don't have the E5 level of licensing. They, however, are in no rush to turn this on for everybody, and the details they've provided are thin on the ground, to say the least. But the logs are now accessible, and they can be made useful and actionable with a little bit of creativity. And that's what we're talking about next. So it's not as simple as it sounds. So this is how we get the logs and how we gain access to these logs and start to see them. First thing that you have to do is to make sure the logs are enabled. There's a couple of ways to do this. You can go to the Purview Compliance portal. The link is right there. And you can enable it via the web UI from there. Or you can achieve the same effect by using PowerShell. Using the Exchange Online PowerShell module, you can run this commandlet here to set admin audit log config, and you just have to set that to true, and that will enable these logs to start ingesting. And the source of that is right there at the bottom. Now, we are going to make these slides available.
Is that sticky?
Sticky?
Yeah. Does it stay set once you set it?
Oh, yeah. Yes, you would. Yeah, you turn it on, and yeah, it'll remain true until you run it again and set it to disable. Yeah, it shouldn't. It should not automatically, disable or anything. Well, I say shouldn't because I mean, Microsoft, but Sorry, I love Microsoft, I really do. But yes, so the source is there. We're going to make these slides available, so you'll be able to get all of this stuff later on. But anyway, so I've got the sources there. All right, so we've turned on our logs. The audit logs are there. They're being created, and they're in the console. But how are we going to see these logs? How do we interpret the raw data? And how are we going to store these logs now that they're getting generated? There's a couple of ways we can do that. First, we can use the Exchange Online PowerShell module again, using the search-admin audit log commandlet. That's a pretty good way to run like an impromptu query. It's not the most efficient way to get data into an easily exportable format, though. We can also get logs via the Office 365 Management API. Spoiler alert, that's what we're going to be doing here. These logs are not natively exportable. There's no radio button in Purview or anything, some kind of slider switch that says, forward these to syslog server at this port. It's not as simple as that. They wouldn't make it that easy. To export the logs to a storage blob or a data lake or a SIM, we're going to have to get creative. Fortunately, the logs are exportable via the API. So here we have it. Office 365 Management API is coming to the rescue. Once we get the data from the API, we are going to need to process, filter, and shape that data to get it into the right format to go into our data lake as a structured set of objects. In the use case that I'm talking about, we use Cribble for this. I am by no means saying that Cribble is the only tool. I'm not here to tell you to use Cribble. I'm just saying this is what we're using. It works for us. We're familiar with it, and that's what we used to process this data. So we have a rough idea now of how we're going to get this data and what we're going to do with it. So our overall data flow looks kind of like this. If you see in the top left up here, the Office 365 Management API is represented there. We're going to get, I'm just trying to see which screen I'm going to point at. Let's go over here. So the API web application is going to be on the left there. That's going to reach out to the API. It's going to get the data. It's going to forward that into our data shaping solution, Cribble, which is there in the middle. Cribble is going to filter the data, process it, get it into the right format, and send it off to an Azure Event Hub, which is on the right in the middle there. And that just serves as a sort of a hub. It's just a location within Azure to collect those events. And then it forwards them to an ADX cluster, which is Azure's data lake solution.
So
Yeah.
you definitely need third-party product for the Office 365 Management API calls.
No.
Azure Event Hub?
You don't need a third-party app. We did because we wanted to do some filtering and some processing on the data. But, I mean, you certainly could just send it straight as an HTTP input into a data hub, an event hub, sorry, or a storage blob. I'm just talking about our use case. So no, you do not need to use that third-party tool. That's just what we did with our use case.
You can even do the filtering and other stuff via Event Hub as well.
Right, exactly, yeah. I've got a dotted line over to Sentinel here as well because if you're using Sentinel as your SIM, then you can also, in our case, if we're getting our data through Cribble, we can also send it to Sentinel SIM here. We didn't do that in this use case. Our client just wanted to get data into their data lake, but you could forward it to the SIM as well. Just saying that's an option too. Okay, so we have a rough idea of what we're going to do. We've kind of planned out our map of what this project is going to look like. So let's take a look at what the API responds with. We're ready to start implementing. We can't wait to see the results of a post command to the API. We've cracked it, haven't we? Right? We've got our solution. We're going to get these logs, and we're going to get them in without E5 licensing. This is going to be so simple. Are you ready? We're going to hit the API endpoint with a bearer token that we got using the API creds that we have from the API, and we ask it for exchange audit logs. Are you ready? This is what it's going to give us. Let's see those logs. Come on. Oh, those aren't logs. Those are web addresses. They're content URIs. They're just storage blob URIs. So these logs are not logs at all. Each line in the audit log that you get back from the API isn't actually a log. It's a link to an Azure storage blob. The actual logs are stored in those storage blobs, not actually called back from the API. So our application is going to have to do a couple of things. We're going to have to send a post request to the API to get the list of storage blob URIs for the time frame we're looking at. Then we're going to have to send a GET request to those URIs and retrieve the logs from there and then forward them on to wherever we're sending them. Are you with me? Does this make sense so far? Okay, great.
Sorry to keep, I should hold these till the end, but
Go ahead.
you said that the post requests are going to get the list of storage blob URIs for the time frame. Did you
Yeah.
also apply other filtering criteria besides time frame, or just sequence time frame?
Not with the API request. No. As far as I'm aware, the only filtering that that API endpoint accepts is date and time ranges.
That actually makes things better.
Yeah. Okay, so we've got these logs, and we want to filter in access logs and just drop everything else. Because the API endpoint is going to return to us all Office 365 mail audit logs for the time frame we've specified. It's going to send us creation logs, deletion logs, logs of emails being sent, everything. We are only interested in one operation type for this use case, which is mail items accessed. That's the only type of log that we're interested in because we just want to see what emails an attacker accessed. So in our case, we used our third-party app, which is Cribble, to configure a route that only sent the mail items access logs to our data lake. And it looked kind of like this. So I don't know how well you can see that, but in this screenshot, there's a line that filters in the route only for logs that have the input ID of Microsoft Unified Access Mail, which is the name of the log source that's pulling in from the API, and also filters for only logs where the raw data contains the string mail items accessed. And then we have an output of the Azure Event Hub there. So yeah, so this route is basically saying only take mail items accessed from this source and send them into the Event Hub. Okay. So we've got our basic architecture for the script. Now we're going to build this out from concept to reality, and we're going to build a serverless app using Node.js. So now we know how to get the logs, which is we authenticate to the API. The API returns the logs. And since the logs are just storage blob URIs, we then send another request to access the logs at each blob. Now let's send them off to our data lake. And this is our use case. You could forward them to a storage blob, could send them to a SIM, could send them anywhere you want depending on your organization's needs. This is just how we are handling this in this use case. So we can use a serverless function for this. The advantage here is we don't need to deploy and maintain a VM to run the app. It just runs as a function in the cloud. It's cheaper than a cloud VM. In our case, we used Node.js running in an Azure function app. But this would work as an AWS Lambda function in Google Cloud Functions, and it can be supported really by any runtime, whether you're using Python or PowerShell. Node.js is just what made sense for our group. And this is how this is how the function app logic is going to work. We're going to get our token, then it's going to list the blobs, and then it's going to take a blob, say blob number 1. It's going to open it up, send it as a JSON object, and then it's going to check if there's blob number 2, and then it's going to go back and iterate until there are no more blobs. Then it's going to exit. Pretty simple stuff. So I've got here a screenshot of the actual code that we've got for getting the token. This just calls the Microsoft Online token API endpoint. This function is how we are going to list the blobs. So this hits the actual audit exchange endpoint within the Office 365 Management API. We give it our token, and then it returns the blobs. We arrange those blobs as an array, and we then take one blob from the list using the getBlob function here, and we process it and post it to our next hop in the process. So we download it, and then we upload it to, in our case, Cribble. Once we've defined all of those functions, this is the main function at the end, which just invokes all those functions and makes it all happen. And that's the entirety of the script right there. Yeah, David.
The blobs contain one blob record each?
They contain multiple logs in each blob.
Some weird number,
I'm not quite sure how Microsoft delineated those. It seems to be like a random number, and they don't seem to be fully arranged by timestamp or anything. It just seems like it just kind of, you ask it to give you, all the logs for a certain time range, and then I think Microsoft just gives you these blobs that cover that time frame, but they don't seem to be fully, arranged. Sorry. I don't think we did. No, I think it's clean. I think it just Microsoft didn't seem too concerned about making the blobs be particularly sensible, if that makes sense. So yeah, but each blob comes in as an array, and then it gets passed out as a JSON array. So, summing up, we get our bearer token. We use that token to get a list of storage blob URIs. We then download the contents of each blob, and we're sending it off to Cribble for processing and filtering. Then the data goes off to Azure, Event Hub, and eventually ADX. Okay. So we've now built our application. We know, we've tested it. We know that we've got something that works end to end. Let's put it to use and imagine what would happen if we had an actual incident. How could we actually put this to use in a real life scenario? So, we got compromised. Okay. We've discovered that an attacker gained access to one of our user accounts and was able to log in to their email inbox. From our organization's MFA logs, we can see that they gained access, even though we had MFA, by sending a request from a suspicious IP address that was then accepted. And we know that the attacker had access from 7 a.m. Universal Time on March 14th to 1:30 p.m. Universal Time on March 18th. What emails did the user access? Well, now we've got these logs, we can actually see that using join queries. Don't we love a good join query? The audit logs only identify the email by the internet message ID. The audit logs that you get from the API don't give things like subject lines. They only give you the internet message ID. So in order to actually get something human readable, we're going to need to do a join query that joins our email events logs, which are an Azure native source that comes in from Office 365, with the audit logs. And we're going to join on that internet message ID field as the unique identifier. And then we can see the sender and the recipient info, as well as sender IP information. So combining those two tables and doing a join query, we're able to see exactly which emails this attacker accessed. And here we have it. So if you look in the top half there, I've obscured the data somewhat because I didn't want to give away too much information here. But we have the client IP address up there in the top in the query. That's what I'm searching on. That's our suspicious IP address that the attacker used. And we can see in the results here down at the bottom, you got the internet message ID, which is the same in both tables, so it's joined on there. And then you see that client IP address in the second field from the left there. And you also get the sender and recipient address and the subject of the emails there. I blurred it all out, but it is all there. So you have all the information you need here to basically determine exactly which emails a suspicious IP accessed during a compromise attack. So, to sum up, we knew the attacker's IP based on multi-factor authentication logs. We can search the audit logs for that IP address, and then by joining the audit logs with email events, we can get the sender, the recipient, and subject information on the emails that the attacker accessed. And we can now report which mail items were accessed from the attacker's IP address and effectively reduce the breach scope. So in closing, kids, do try this at home. I'm just going to say we will make this function app code available on our GitHub. The link is there. Again, we're going to make these slides available, so you'll be able to get this. But that's our GitHub page, and we will post this code there at some point. Not yet, but it'll be up there soon. And we're also going to do a full write-up of this on the SRA blog. So again, make a note of that URL there, and we'll make this available as a full write-up there as well. Watch those spaces for updates. One final recap then. Microsoft is making premium audit logs available. You need to turn on the audit logs to make use of them. You can forward the logs to a SIM, a data lake, or a storage blob using the 365 Management API. And as is often stated, knowledge is power. So now you know exactly what an attacker accessed, and you have the power to limit your risk exposure as a result. That's all I have. Ready to take any more questions from people. David, yeah, okay, one more.
You mentioned when you did the join, that's the last step there, using Outlook email event logs, were those already available, or is that part of what Microsoft has made available?
No, those are already available. That's part of the Defender. Yeah, Defender for Office. No, it's not even Defender for Office 365. It's just Office 365 logs that you can connect to. Say, if you're using Microsoft Sentinel, you can connect them to your Sentinel instance using a native connector. And then what we do in our environment is we replicate those logs into ADX for long-term retention. So yeah, but that is out. That has been available for a while. That's not part of what was just made available. The only thing that's new is these unified access logs, which we can get from the API. Yeah, I had a question from over here. Oh, Google comes to the rescue as well. That's cool. Yeah, well, there's a bunch of them. The big things that I can think of right now are OneDrive file access logs, SharePoint access logs as well. All of those things are now available via the same method. You just hit a slightly different endpoint, but yeah, it would be the same method really. It's pretty much pretty simple to modify the app to hit those endpoints too. What? Who isn't? Oh well. For some reason I was like, what? There's someone behind me? Okay. Okay. No, it's all good. It's all good. Yeah. Any other questions? I think right at the back there. Yes. Hi. So yeah, no, good question. I'll be honest. This is a hypothetical situation, right? So this wasn't an actual incident. The logs are real. The incident wasn't. But you could certainly you could configure an analytic in your SIM to look for, suspicious geolocation of an MFA request, and you could monitor for that, and your SOC could then investigate when that kind of a request comes in, even if it's accepted. That would be one way that you could tell. There's a number of ways that you could tell that it's compromised, but I mean, I think that would probably be the first thing I would think of, was just to develop an analytic that would trigger with a suspicious geolocation for a multi-factor authentication request. Anyone else? Oh yeah, hi. I don't think they're natively made available via Data Explorer or anything like that. The way to access those storage blobs is to make an authenticated API call using a bearer token. So I think the API is probably the only way to get at those storage blobs. I believe so, yeah. Yeah. Cool. Any other questions? Going once? Going twice? All right, well, thank you very much. Hey, we've even got a few minutes to get to the next talk. Hey, awesome. All right, well, stop by the SRA table on your way out. Grab some stickers. Thank you.
This is how I react when I get engaged with a topic.
Yeah, no, great. No, you were asking good questions. This is all good stuff.
I do have another question. It's basically, because I think you may have some not relevant to this exact. We get a